some polar graphs here. Now, I'm going to demonstrate a little bit and kind of go through how one would create a polar graph. It's a really tedious exercise, and that's one of the reasons why, oftentimes nowadays, whenever you're asked to produce polar graphs, say, hey, whip out the calculator, put the formula in, and see what happens. Excuse me. You have to worry about step values and things like that, but that's not a major concern. We're not really concerned about graphing these that much either in this course. But, just like, a standard function is usually written with y in terms of x, a polar function is written with r in terms of theta, where r, the radius, is dependent upon the angle theta. So here, if I have r equals 6 and I have no angle theta, it's like me having like y equals 6. That means that, on a regular coordinate system, that meant like, okay, well, y is always 6, x could be anything at once. And that ended up being a horizontal line. For this, though, the radius is 6, so as long as I'm 6 units away from the center, it doesn't matter what the angle theta is. And so what I would end up having, if I was scaling the graph as so, is I'd have a circle with a radius of 6. So that's what it would. So basically, we're like a very basic, y equals a number was a horizontal line in a regular coordinate system, and a polar coordinate system, the basic, line for like r equaling a number is going to be a circle. If I wanted to graph something more special, like something that I did have an expression in terms of theta being equal to r, I'd actually have to go through a process, much like we did when we were dealing with our x's and y's. We would pick some x's, find out what the y value is. Well, here I would pick some theta values, and I would figure out what r is for each one of these. And so I'd pick my special angles. So I would take, 0, do 2 times that, do the cosine of that, multiply that by 3, and get an r value, and do that for each and every one of these angles. And if I did that and calculate these and plot them, and the other thing I have to make sure I do is I plot them in the order in which they come. So I start at 3, 0, angle 0, 3 out, 1 point, pi over 6, I'm at 1.5, and I make sure I connect the dots in that order. I would get this like kind of little 4-petaled flower pattern here. And likewise for part C, if I was doing r equals -2 times the sine of theta, again I would set up a graph, picking some theta values. Again, angles I could find the trig function values for based off of me knowing my standard values, and I would calculate the r values. And what I would get here is this kind of circle, which has the edge at the origin. So, but you're not going to be asked to plot these or produce graphs. I just want to give you a heads up of what they kind of look like. The only thing about polar coordinates you're really responsible for is being able to convert 2 polar coordinates from a regular x, y coordinate and vice versa.